Hello, my name is Rob Garner. I'm a computer programming instructor, and today I'm going to demonstrate how to use character arrays in C++. So we can open up Visual Studio, and I'm going to create a new project. And we'll make a C++ console application, and we'll call this character array demo. I'm going to select the desktop, click OK. I'm going to make this a empty project. And in the Solution Explorer, I'm going to add a new item, a CPP file, which I'm going to call character array demo. I'm going to start off using our standard C++ code. We'll include IOStream for output, namespace standard, some comments, and the first thing I'm going to do is declare a string. Next, I'm going to initialize a character array, 20 elements, and initialize it to I love C++. So we can initialize a character array after we declare it by assigning it equal to essentially a string. Next, I'll declare another character array. I'm going to call this one no null text because we're going to initialize it in a way that doesn't put a null item. Character arrays are called null terminated arrays because when we initialize an array, by default it will set a null character at the end of the array. If I were to assign each element individually, So what we have here is an array that's been initialized each character individually, and this will make it so that there will be no null character at the end of no null text. The next array we're going to declare will actually just be declared, but we won't put anything in it or initialize it. So on the surface this looks fairly simple. We have a string object that we're going to display. We have a 20 character character array, one with no null text, so there's no null item in it, and one with no text. And because we do have strings, we do need to include string, although realize it's not needed for our character arrays. And we see that we get kind of strange results. So our string object displays normally. Our C++ love object, which was defined up here, where we assigned a string into our 20 character array, that came in okay as well. But when we displayed no null text, it says whoops no null, which is actually what we placed in no null text. But then it has all these weird characters to display, and it displays I love C++, which is this element here, and you can see we didn't display that. We didn't repeat displaying C++ love down here. Instead, it just prints out this odd character all the way across and then displays the previous string that was defined before. And if we look at this last one, we get the same thing. It displays this uninitialized no text array as a bunch of just random characters, or not random characters, but these odd characters, then displays our array up here, and then more characters. So this part under no null text, it displays that same part down here. So what's going on? let's take a look at the initialization code for those arrays. So the first one's a string object, and when we declare things, they're placed on in memory in inverse order from the order that they were declared. So string object gets placed on the right side here first, and then CPP love gets placed next, and then no null text, and then finally no text. And the string object is this whole string here. CPP love is this 20 character array, and at the end of that the character array, you'll have null characters for all the all the way till from the end of I love C++ exclamation mark all the way to the end of that character array. So realize that there's a null character here represented with a /0 that's placed in that character array. The array where we declared every single item directly won't have any null characters, and what will actually be in characters 14 and on are basically whatever was in that memory space before, or typically it's the largest negative value for that data type. And then over here under no text, we declare an array, but we don't set it equal to anything, so nothing will initialize it with a null character at the end. And what ends up happening is this: when we write this code out, the string object will display normally. The CPP love object will also display normally because we just set that text into that variable, and it displays the way we'd expect to because there's a null character at the end. The no null text, however, where we set every single character explicitly, doesn't have a null character. So what happens is it displays the characters it has, and then for every other character it displays this odd looking character, and these will just be displayed for every character that's from the end of whoops no null all the way to the end of that character array. And then it'll pick up with the next character array. Because there's no null, nothing stops the buffer from pushing more things out to see out. So it just keeps going on, and it displays the next variable or the next array. So it just keeps going on until it finds a null, and in this case it's only going to find a null when it gets to that variable, or to that array. Then next, when we try to see out the array that wasn't initialized at all, again it keeps going through, displays strange characters for each element of the no text array, then goes on and displays everything in no null text. And because it doesn't reach a null, it keeps going on until it reaches a character array that has a null. And when it gets that null, then it stops, and then it's completed. The next thing we're going to demonstrate is how to input character arrays. So I'm going to get rid of the code that I put in so far. And let's say we declared a character array. I'm going to just call it Char Array, and we're going to input 25 characters. And what we're going to do is ask the user to input some text. In order to get that input in from the user, what we're going to use is a method of the cn class. If I put cn and hit a dot, cn is actually a class, and it has a number of properties and methods associated with it. The method or function that we're going to use is the getLine method. And the getLine method takes two parameters. The first is the character array we want the results to end up in, which in this case is char array, and then the number of elements that we're going to input, which is 25. And then just so we can see what was input, we'll see out that back out to the screen. And I'm putting an end line at the beginning because when you get line this way, it doesn't put a character return at the end. It's different than the string getLine function. So we have to put a carriage return so that it goes to the next line after the user inputs their information. So we're going to output char array and end of line character. If I run this, and we see that we do in fact get some user input text. Notice that it truncates after 25 characters, so you have to make sure you input the right number of characters. But otherwise it works fairly well for inputting text. So again, the key is cn.getLine, the character array you want to input, and then the number of characters to be input. Another type of input that we may get is we may input some information from a user and want to convert that to a number. So let's say we declare a character array, and we're just going to call it buffer. And let's say we want to input a integer number and a float number. Well, let's get int from a user, and what we're going to do is cout, please enter a whole number, and again we're going to use the cin.getLine, and we're going to tell the computer that we want the input to go into this array we called buffer, which is a character array, and buffer has 25 characters, so we're going to put in please bring in 25 characters. And then in order to use it, we need to convert it, so we're going to convert it using the ASCII to integer function. And what that looks like is I can say take num1 and assign into it atoi, which is the ASCII to integer function, and then it takes one argument, which is the character array we want to convert, and what it will do is it will convert that character array that we got from the user into an integer if it can. Then similarly we want to get a float from the user, and so again we're going to see out some instructions to our users. We always tell them what we want them to input. And I'm going to use cn.getLine again. I'm going to actually reuse this buffer, so that buffer will now have the new input. And then I'm going to set my float number equal to atof, which is ASCII to float function. And then we'll show the results. And just to prove that these actually came in as are now numbers, we're going to say the sum is and so I'm going to enter a whole number. And then a decimal number that converted to an integer, a float. Oh, looks like we have something going wrong here. Let's take a look. I didn't declare my float properly. Let's try it again. Because I declared it as an integer, it converted it to an integer. So here's my whole number, here's my float, and now I get the result expected. The float was 4.444, the integer is 7, and the sum is the sum of the two, which, by the way, because of the way C++ does math, if you add a float and an integer, it's going to return a float. And so it did what we expected. Next exercise, let's say we wanted to create a function that built an address label. Well, I would need a character array for the first name, middle name, and last. And we're going to have an overall one for name, address, and city. And so these are all arrays that we'll use to collect information we need in order to create an address label. And then we'll get some information from the user. And again, we'll use cn.getLine. And repeat much the same thing. We also need to make sure that these numbers are correct. City is actually 30. Address is actually 50. Those three are all 20s. And that should get all the info I need from the user. Now we need to build a name, and we don't want all these, we don't want first, middle, and last in separate variables. So what we're going to do is we're going to string copy. This is a character array function which we put in the character array we want to copy into and then the character array we want to copy from. So this will take last and copy it into name. And then next what we're going to do is we're going to use the string cat function, which is a concatenation function. And we're going to specify the first element, and we're going to put a comma and a space. And what this will do is it will concatenate a comma and a space after last name, because normally we put on address, last name, first name, then middle initial. So this allows us to reorder that information. And then we're going to put in the first name, again using the concatenation function, and then we're going to concatenate name with a space, and we just want the first initial, so we can actually use the string cat function this way. We can put a name, middle, but we're only going to bring in one character. So that one says just bring in the first character of middle. And because we want a period typically after we have just an initial, we're going to concatenate the name, comma, and then a dot. So that'll put a period after the initial. So we're going to start off with last name, add a comma, add first, add a space, add just middle initial, and then add a period. Finally, we'll display the results. So typically what we'd expect, we have the name, the address, city, state, and zip code for mailing address. And we seem to have an error with this function. Too few arguments. String concatenate, we have name. So let's try that. So the difference between string cat and str cat. Notice if you put string cat and just put a 1, it doesn't work. We have to have the n. It's a different function. So if I run this, actually I want to put in a full name. And we can see that it does format our mailing label. Using string concatenation, copied name in first, concatenated in, so even though I put Robert John Garner, it concatenated it in the reverse order, put the middle name last and only used the initial, added in a dot, and then displayed the rest. This completes my demonstration. Thank you very much.